Hey, Andy here. Thanks for joining me on a new video. A bit cold in the garage today, 12 degrees, winter is here. So if you're new here, you are very welcome. If you're a returning viewer, many thanks for your continued support. So, the thumbnail may have been a little bit clickbaity. You're not being cheated, but you may be slightly deceived is even a strong word. You need to check your firmware to make sure you are getting the speeds that you're asking for when you're putting your speeds in your layer in either Lightburn or Laser GRBL or whatever firmware, even the longer LaserBurn. You need to make sure your firmware can match your speed you're asking for. And in this video, I'm going to show you how easy it is to check and to take any apprehension or fear away that you may have in adjusting your firmware. There's two ways we are going to be showing you how to adjust the firmware. One is in console, so you're typing some letters in, and the other one is using the menu system in Lightburn. Anyway, grab yourself a cup of coffee. This video is not technical, but you are going to be altering some parameters in your firmware to make sure when you ask for, let's say, 10,000 millimeters a minute, because behind me I've got my Ray 5 20 watt module on here. Don't worry about this thing here, that's my fine focus system, and don't worry about that thing there, that's my flame detector. Again, I've got videos and all of that. My channel is full of, I would say this, informative videos that do not appear on other channels. I've got lots of videos on lots of the longer lasers. So this is my Ray 5. I cover 5 watt, 10 watt, 20 watt and 30 watt on there. I've got a Ray 5 mini. I've also got a B1. So if you're interested in any of those, you can do this exactly the same process I'm going to show you here on that laser, because I haven't checked all firmwares for all lasers. Now if you haven't got a longer laser, you can follow along, because generally, I'm going to say most, I can't say all, diode lasers work on GRBL code. That's the firmware that we flash. So when you download a bin file off Longa's website, that is code that we load into our controller. So we load onto our screen down there for the 10 watt, and we hope that it's correct. Now I found on my 10 watt through recent testing that I was not getting the speeds I was commanding. So in Lightburn, if I put in 10,000, I was only getting 6,000. In this video, I'm going to show you exactly what to do, how to check your firmware, and how to increase speed values, and more importantly, $30 value, to make sure that when you're asking your laser module here to burn at, say, 70% power, you're actually getting 70% power out of your module. Because if you've got these numbers wrong, you may be only getting half of that, and no one wants half power. We all want full power. More power, Captain. So let's get into the video.
And good morning or afternoon to wherever you are in the world. I'm Andy. Welcome to FlixMySwitchLASER. If you're new here, you are very welcome. If you are a returning viewer, many thanks for your continued support. I do apologise about the sound quality. As you may see from the background, I am not at home. However, I feel this video just has to be made, and made quickly. It's going to be another week or 10 days before I get home. And I've just been working on a video, and during making that video, something really important has cropped up, which I feel deserves a video on its own, released prior to the one I'm working on. So what is that? You've probably seen from the thumbnail some dollar codes. Now, some of you may not have ever dealt with dollar codes, but these are the fundamental settings that configure your laser or CNC or anything that's running sort of GRBL code, and those dollars equal something numbers tell the machine how fast, how slow it can go, whether something activates when it's positive or negative signal. So you can quickly see if you've got some of the numbers wrong, you could be losing one physical laser power, or for the CNCers, spindle speed, or travel speed. And they're the three things I'm going to highlight this morning. So there's several ways. Now I've just downloaded, and I've actually got my code loaded on an ESP chip because I'm not at home, but you can flash a normal ESP32 chip with the firmware that drives your laser, and that's exactly what I've done. So I use longer products. So I've downloaded the firmware for a longer 10-watt laser, but I'm pretty sure, and now I haven't checked all the firmwares. I've written to Longer to say, can they check them and please explain this error? Yeah, I think it's an error on their part because they advertise one thing and their firmware gives you another thing, and it's not in a positive direction. So they're not doing you any favors. So let me explain. So the easiest way to explain this is if I go back to, let me go back to here. So when you've downloaded the firmware and you unzip it, it gives you a file. Now in the tools, I think that tells you how to flash the firmware. The firmware is, this is the bin file you would actually flash into your laser controller. So that bin file is now living on this chip. So this is my laser. Then, so let's go back. The README is what modifications they've done to the firmware. So you can read through that if you're interested. And again, you only need to update firmware if you've got a problem. If your laser is working well, I would say there's no need to flash the latest firmware. Then configuration, this is the one we're going to come back to in a minute. And then the firmware guide, I think that then shows you, yeah, that tells you actually how to flash the firmware and what to do with the configuration file. So we close that and we go back to configuration file. Now, what I like about this file is that if you know nothing about the dollar codes, at the beginning of the file, you can see these forward slashes and the stars. I mean, these are just comments, so this doesn't get flashed to your controller. But if someone mentions to you on a forum, oh, what does this dollar code mean? You can look up in your own configuration file and you can see. So the ones I've highlighted today are $30, and that's maximum spindle speed. So if you've got a CNC, that means it's going to allow the spindle to rotate at maximum speed. For us diode lasers, it means that when we ask for, say, 70% power, it will give well, that's another story. I'll stick to that. If we ask for 70% power, it will give us 70% power. But that statement is not actually true, and I will cover that in another video. It's actually a duty cycle that it gives you. So instead of that's going to be, I need to do a video to explain that. But let's just say this dollar code is all about, if you ask for 50%, the laser gives you a true 50% of the diode value. And when you're cutting or burning, you will notice that if you're using 50%, it may be a light brown color. And if you engrave at 100%, which I never recommend, you should never need 100%, it will be much darker. If you're cutting at 50%, you may need 2 or 3 passes. Now, if you're cutting 100%, which some people do recommend, you may only need 1 pass. So $30 is all about making sure that when you ask for a percentage of power, it gives it to you. And the other ones I'm going to talk about is 110 and 111. And that's telling you x-axis maximum rate and y-axis maximum rate. And that is all about the speed the laser can travel at. Now, there's other ones I can talk about, but I'm not talking about those today because I really want to ease you in to the subject of do not be afraid of dollar codes. Do not be afraid to experiment. I'm going to do some more videos later on where I really experiment with these, and I really push the laser till it fails. And then I'm going to wind back the codes and then say, yeah, this is the maximum I'm happy to use my laser at. And we're going to be talking about travel speeds and acceleration speeds. And anyway, it will come clear when I get to that video. Now, as I say, these are only comments. So if you scroll down, now these numbers here are the actual numbers that are going to get flashed into your controller. And if we look down here, $30 is 1,000. Bear that in mind. And 110 and 111 are 6,000. So let me just bring up another screen. I'm going to pause. No, I'm not going to pause the video. Let me just bring up another screen. I am going to go to engravers. No, Ray 5, because that's what I'm looking at. I'm looking at the 10 and 20 watt. Now, as you can see, Longer have their Black Friday sale on because it's 19th of November at the time of recording this video. Anyone looking for a laser, I think that's a bargain price, so have a look at that. Now, if we look at some of these pictures down here, engraved fast at 10,000 millimeters a minute. They're actually stating that in their advertisement, but you're not getting that. Okay, so look at that, 10,000 millimeters a minute. And I just showed you in the firmware that you're only going to get 6,000 millimeters a minute. Now, if you're a CO2 user, your speeds may be the same. Instead of getting, let's say it's going to be 6,000 millimeters a second, it's never going to be that fast, but whatever that converts to in millimeters a second, if you want to make sure you're getting the advertised value of your laser, you need to check in the code that the code actually will allow you to get it. Because if we go back to Lightburn, and if I draw a simple square, I put that on the red layer and we go to layers, I can, in here, I can say, right, I want 10,000. That is 10,000. Okay. Now, if I send that to the laser, if we say start, okay, the laser has burnt. Now, I said I'm on a chip. So what that's actually done, it hasn't moved any of the motors because I've only got a chip. But the G code from Lightburn has been sent to the controller. The controller has understood it, and the file is completed. However, just because we have 10,000 here doesn't mean to say the motors are going to move at 10,000. So this is a copy of the G-code file that it's sent. So I just redrew a square with the same speed and sent it to the laser. This just proves to you that it does send the command of 10,000 millimeters per minute to the laser. It's stating it here, so that's just a comment. But in here, the G1 command, it's telling it F 10,000. It's saying move at 10,000 millimeters a minute. But we know the actual firmware is not going to allow the motors to move that fast because the firmware inside is going to stop it. Lightburn will not throw an error because it can send the G code to the controller and the firmware can read the code, so there is no error in it receiving the data. Now, I will demonstrate this when I get home because I do a part 2 to this video to prove that I'm not talking a load of baloney. So, how can we make sure that our laser is traveling maximum speed? First thing you need to do is make sure you've got a well-tuned laser. And by that, I mean that when you've adjusted your belts on your laser, that they're not as tight as a guitar string. Okay, they need to be firm but not overly tight. Because if you, when you're adjusting the belts, if you really pull them, and then you do the adjusting that up. I'm going to do this up as tight as I can because tight must be better. Tight is not better. It's better to have a loose belt than a very tight belt, because if it's very, very tight, what you're doing, you're stressing the bearings on the stepper motor. You're going to get the stepper motor making some horrible noises. So when you're adjusting the belt, it needs to be a little tug and do the screw up. Now, you normally have two belts either side, or one belt either side. You need to make sure they're roughly the same tightness. So that's the first thing you need to do. Second thing you need to do is you make sure that your wheels are running smooth. I'll drop a link about my eccentric nut video. I can't remember, is it 6 or 10 minutes long? Very, very important that you get that right, because then when we ask our laser to travel the extra 4,000 millimeters a minute, we know it's going to do it smoothly. So that's one video I urge you to go and watch. I'll leave a link in the description, and I'll post a thing on the screen there to remind you to go and watch it. So if we go back to, now there's two ways to see all the commands. If you go to console and you type $, it looks like the screen didn't change, but you can see here I now need to scroll down. So if you scroll right the way down, this now lists all my dollar commands. And you can see that $1.30 is 1,000, because that's been correctly set in my instance of my firmware. Now, if you're using Laser GRBL, I believe that needs to be 10,000, because you add an extra naught onto all your settings, I believe. Now, I can only speak for Lightburn users. And if we scroll down to 110, 111, it says 6,000. Now, another way to see these values is if you go to Laser Tools and Machine Settings. Sometimes you may only see that. So you can set on general settings. We're not going to change anything in that today. Home in, again, we're not going to change anything in there today. But output settings, it tells you here, you can see you have to look for the dollar value, and then it tells you what it is. And if you want to change one, so today we are going to change X max rate millimeters a minute, $110, and it's set to 6,000. So I'm going to click on that, and I'm going to use the backspace. I'm going to change that to 10,000. Click off it. You see it's 10,000. Then I'm coming down here. Max rate again 111 is 6,000. I'm going to click on it. I'm going to delete that and put 10,000. Click off it. So then I'm going to write it to the controller. Written successfully, reconnecting. Okay, so I'm going to say okay from that. Now, if I do $, here, which again is going to read the settings in your controller, scroll down, you can see that 110 and 111 are now 10,000. So now if you have 10,000, and I'm sorry to disappoint you, I doubt with a diode laser you're ever going to be engraving at 10,000 millimeters a minute. Possibly with a 40 watt, I can't tell you that. I may try it with my 30 watt, but a normal engrave speed will be somewhere around 6,000 to 8,000, depending on your power. However, the reason I want to talk about having the ability to run at maximum speed is Whitespace. Now, let me just alter this. Let me just make this bigger. And then I'm going to do an offset of, or let's go 10 mil so you can see it. And we'll change that to fill. Okay, so that's a rather large square, which is, let's make that, lock that on, change that to 300. Okay, so that's the 300 square. Now, if we're engraving, so we're filling and we're asking 10,000. Well, let's change that to 6,000 like we were before. 6,000. Doesn't matter about the power because I'm not actually going to burn anything. So let's see how long this engrave will take to burn. So if we do the preview, it's going to take, again, I've turned some settings off here to highlight the issue. 2 hours, 42 minutes. Now, if I just play that, you'll see the lasers traveling backwards and forwards. Now, it's okay on the bottom bar because there is no white space. But now, when it fills the bottom bar and it starts doing the sides, let's just wait a second. Let's just move this on for you. You can see that the engraver is only powered on here. When it travels across this white space area and burns that, this is wasted time because when it's traveling over white space, it's doing nothing for you. So there's lots of ways that you can change the way you can save time. One of the quickest ways, so I am back home now and I can hear you all screaming at the screen, Andy, 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 use offset fill. So I've just drawn another square here, 300 with a 10mm offset, and you can see on standard fill, it's 2 hours, 10 minutes, okay, on my settings on this machine. So that's obviously a long, long time. Now, what offset fill does, instead of the laser going backwards and forwards, left to right, it will follow the shape. So in this case, it's going to draw a square. But let me change this to offset fill. And then we do a preview. You can see, look, we got rid of all the red, and that's one aim of this video. But this only works for simple shapes. If you've got something like a clock face, so you've got a round dial with the numbers around the outside and maybe an engraving pattern on the inside, you won't be able to use offset fill because you'll end up with lots and lots of white lines inside your fill. So if we just look at this, it's now 20 minutes 36 seconds. If I press play, you can see the laser head is following the shape that we've drawn. Now I've drawn a simple square. So yes, you can save time on simple shapes using offset fill. I know in the example later on, I divide a square in half, but again, that just gives you an idea of how you need to think ways to reduce your white space. So if you take my example in a minute of splitting a square in half, just imagine that's a clock face, and I think you'll get to my way of thinking and the logic that I'm using. Is sometimes you can divide the project in half. So there, very quickly, I've cut this square in half and then join the two halves together and put them on different layers. I've still got the same speed, but now if we look at the preview window, it's down to 59 minutes. And if I just play that, you can see now it's doing the first solid bar at the bottom. Then as it goes up the side, there is going to be no white space. You can see it's just engraving there. And the red, if we zoom in, this is just the overscan. So we'll just let that complete. No, we won't let that complete. Now, overscan is the faster you travel and the heavier your laser module, the more overscan you need. And the overscan allows the laser to slow down, stop, move up or down one line, speed up again. So if we click on any one layer, you can see, look, my overscan is set quite high. If I drop that down to 1.5%, that's gone from 1.5 millimeters. So that's reduced my travel time by 1 millimeter. So if I just change that to 1.5, because I'm only using the 10 watt, and I do that one to 1.5, and then we look at the time again, you can see, look, it's now nearly 57 minutes. So it saves a bit of time because this distance, there's the edge of your project, and the laser's coming across, it's slowing down, dropping down a line or going up a line, ramping up in speed, and it starts burning here. So setting your overscan can save you time. And just to highlight that, if we think we can get away with another one, they're changing that to 1 mil. Again, it's only you're only saying, look, I've only saved in 0.5 millimeter, but yeah, it hasn't saved you much time. But from nearly 59 minutes, it saved you 3 minutes. Again, use the settings your laser manufacturer recommends. I've always found that 1.5 works. So I was just highlighting the issue. You should never now. Those clever people thinking, well, let's turn that off. So let's leave that at 1.5, and we'll turn overscanning off. And we'll turn overscanning off. We just see what it does to the time. So yeah, look, brilliant. I saved a lot of time. What that is going to do, it's going to, what happens is, if we zoom in here, the laser will turn on here, burn, 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 and it never turned, well, that's slightly wrong. The laser is going to turn on at the bottom, and it's never going to turn off because it turns round. You can see it's turning round dead on this line. So what's going to happen is, when it's doing that, going up, it's still going to be burning at, in our case, 80% here. So what you're more than likely get is a dark edge down here. So overscan is there for a reason. Never turn it off unless you need to for a special reason. But have it adjusted correctly so you save time. Okay, so now Whitespace. So we've got rid of our Whitespace. Let me just move this off and we'll draw the other square back. Now you can see now here we go back to, that's on a terrible slow speed. So I need to change that to, we had that on 6,000 as speed. Fill bidirectional 1.51, 1 pass. Okay, so let's see what the time is now. Okay, 2 hours 35. Because we're now traveling across the white space area, and if you've got a design which you can't divide in half like I just showed you, you need to come up to the spanner, basic settings, and make sure white space, fast white space is turned on. Let me turn that on, and I'm going to adjust that to 6,000 because that's what our original firmware only allowed us to do. Now if we look at the time, it's come down to 1 hour 47 minutes, purely because when the laser is traveling across white space, it is now going to travel at 6,000. But I've just shown you how to make your laser travel at 10,000. So here we are at 147. So if we go back to white space, and now we can say, I want that to travel at 10,000. And we look at the time. Why has that not changed? Andy, yes, that's a really good point. Why didn't it change? Yes, you've forgotten what they taught you at school, haven't you? I have. So what you've got to remember, there is a trade-off between speed, acceleration, and deacceleration. So as we know, the laser is going to say start at the bottom left-hand corner. It's going to do that bottom bar, and it's going to work up here. So the laser is going to come past here, and as it leaves, it's going to, as the laser comes past this line, it's going to turn off. It's going to use the overscan settings. It's going to come out here. So it's slowing down. It's then going to go up a line. It's then going to speed up. So when it gets there, it's going to be at 6,000 because that's what we set our burn to. So it's going to travel across here at 6,000. Then it's going to turn off. Then as it goes across the white space, it's now going to accelerate up to 10,000. It's going to get other side here. Then it needs time to slow back down to 6,000. It will turn on here, burn at 6,000, turn off there, go out, start slowing down, stop, go up one line, accelerate back up, get to this point here where it will turn on at 6,000, go across here at 6,000, turn off there, then it's going to accelerate to 10,000, go across. So there comes a time where going faster, it increases the acceleration distance needed to get up to that speed. So it's not actually going to reduce your scanning time, as that has proved in the preview that I've just shown you. So I hope that makes sense. I was scratching my head for a little while, then I remembered what my physics teacher taught me, and it became crystal clear. So I touched on $1.30, and as you can see here, in our lasers, $1.30 equals 1,000. So what you have to do is make sure that in your basic settings again, S value max must equal 1,000 as well. Your laser GRBL, I believe yours is 10,000 here, and your $1.30 is also 10,000. I don't know why you add the extra zero, but I know that's how it works. So that will ensure, as I said earlier, that when you ask your laser for 50% power, it will give you 50% of your optical power of your laser.
Here I'm demonstrating a test. It's a small rectangle. It is 300 millimeters wide by 1 millimeter high, and it's engraving at 6,000 millimeters a minute, and that's the speed set in my layers, and the dollar code in the firmware is set to 6,000. So let's start the test. It should take about a minute. So you can see in real time how slow the laser is moving. And according to the Lightburn, it's still saying busy, 25 seconds, 26, 27, 28, 29, 30, still going, 99%, 35, 36, 37 seconds that took. So now I'm going to adjust the speed to 10,000, but keeping the firmware setting at 6,000. So I'm just going to change that in Lightburn now, 10,000, and going to redo the test. So that's the same test. And if I superimpose these on one another, I do believe that that speed is going to be the same, because although in Lightburn I've commanded 10,000 millimeters a minute, the firmware is stopping it at 6,000. So it's 99%, 32, 33, 35, 36, 37 seconds. So now I'm going to change the firmware using machine settings, and I'm changing $110 to 10,000. I'm going to write that to the controller, accept, and now I'm going to redo the test. So this is 10,000 in firmware, 10,000 in Lightburn on the layer settings. So let's just start. Now you can clearly see and hopefully hear the motors are sounding much different because we are travelling faster. 99%, still going, 18, 19, 20, 22, 23 seconds. So that proves I'm not speaking a load of baloney. You have to make sure your settings are correct in firmware, as there is no error check. And this is not pointing the finger at Lightburn. Lightburn is doing exactly what Lightburn should be doing. You just got to make sure your firmware is correct, as I've shown you in this video.
So that's it. Well done. You made it to the end of my video. I did mention in the video that I am working on fast engraving videos, and I know my webcam is not very good, but that was engraved at 15,000 millimeters a minute. And I will be revealing the secrets inside the upcoming video for that. So if you're interested in how to go above and beyond your manufacturer's recommended settings, I'm going to push my laser to the limit, wind it back a good percentage, and then show you what the secret sauce is.
So here's a quick preview of another video I'm working on. This is a video to show you that you can engrave on certain materials with faster speeds than the machine can run at. Now this is set at 15,000 millimeters a minute. Yes, recording. "15 seconds, 16, so that's completed in 16 seconds. That's just a preview of what I'm working on. So if you like what I'm doing, please like, subscribe and comment so not to miss the video. So those of you who've stuck around, here's a longer Ray 5 moving at 30,000 millimeters a minute. Now I say moving, it's not engraving. This is only a 20 watt laser and I doubt whether it will engrave at 30,000 millimeters a minute even at 100% power, but just to prove that when you're tweaking firmware you can make the thing run faster. Now listen to the sound and look how fast it's moving. 30,000 millimeters a minute. Now on certain materials I'm sure we could get that engraving, and I didn't see how quick. I'm going to run that again. Same test, just checking what the time says. Where it's in Lightburn saying busy, that's the time I'm looking at. 10 seconds, 10 seconds, that completed it in. So yeah, if you're interested in what I'm doing, like, subscribe and comment so you don't miss any experiments. So Andy from the future here, one really important point is if you adjust your firmware settings to 10,000 and you have been engraving, because you probably won't be cutting anywhere near above 6,000. So if you've been engraving say at 7,000 when your firmware was limited to 6,000, if you adjust your firmware, let's say you set it to 10,000 like I showed in this video, it will adjust the result you're getting on the material that you've been engraving at 7,000 when your firmware was restricting it to 6,000. Because as I've demonstrated in this video, if your firmware was on 6,000 and you've been putting in 7,000 on your layers, you're not getting 7,000, you're only getting 6,000. So now if you're trying to engrave quicker and actually engrave at 7,000, you will have to increase your power to obtain the same result on the material that you've been doing. So you will have to do a new material test, because technically you can now engrave up to 10,000 at 100% power if you wanted to try and reduce your burn time of your project. So if you take anything away from this video, if your firmware was on 6,000, now you've changed it to 10,000, please double check doing a material test your burn settings, because they will become lighter because you're now traveling at 7,000 if that's what you're asking for. But because you're still at the same power as you were, your finished burn will be lighter. Anyway, hope you follow that. If you don't, drop a comment down below and I'll try and explain it better.
Anyway, if you got some value out of this video, please consider liking it, dropping a comment down below, and if I've earned your trust and respect, How about subscribing to my channel so you don't miss out on any upcoming videos? Anyway, that's Andy, as ever, wishing you a great afternoon. Continue to make that happy, safe smoke, and perhaps you'll join me in my next videos. Cheers for now.